Okay, hey guys, Sean here from broadcasting from Rancho Cucamonga, California. Um, I'm hopefully going to make these videos really short. I'm going to be doing a Chapter 5 and Chapter 6 review for you guys for statistics. I'm going to start in Chapter 5 and do probably like a 30-minute video or so, and then I'll post another one a little later on Chapter 6. And don't forget that if you guys have any specific questions that I don't address here, feel free to email me or text me, and I'll do my best to get back to you. I know you guys have the test tomorrow, so I'll do my best to get back to you as soon as possible. Okay, cool. So we're going to start with 5.1, number 11. And just so you guys know, I'm going to be moving pretty quick. So feel free to watch these videos over again, or like I said, ask me any specific questions that you might have. Okay, cool. 5.1, number 11. So that's the marketing income question. And we're only going to do parts C and D, because that's the only parts that she addressed and said that you guys would need to know how to do. So, and it would be good to have your book open to 5.1 to this particular problem so that you can follow along. Okay, so what is the income distribution of super shoppers? Okay, and then they give us a table that includes the midpoints for each category. And part C says compute the expected value mu of a super shopper. Okay, so real quick, we need to write our formula for mu. So that would be mu, which is also known as expected value, is the sum of x times the probability of x. Okay, cool. So we've got 1, 2, 3, 4, 5, 6 x values. So we've got 10, 20, 30, 40, 50, and 60. So those are x values. And then we have our probability value for each of those, which is given. So we've got 21%, which is 0.21, 14%, 0.14, 22%, 0.22, what is that? 0.15, 0.20, and 0.8. Okay. And we're doing part C, just as a refresher. So that, and part C says to compute the expected income mu of a super shopper. Okay, so all we're going to do is multiply each of these individual x values times its probability. So we're just going to be multiplying these values. And then we're going to be totaling them up. Okay. So I'm going to pull out the calculator here. Okay. So that would be 10 times 0.21, okay, is 2.1, 20 times 0.14, 2.8, 30 times 0.22, 6.6, okay, 40 times 0.15 is equal to 6. 50 times 0.2 is 10, and 60 times 0.08, excuse me, that should be 0.08 times 0.08 is equal to 4.8. Okay, and then we get the sum of all these, because that's what this is asking for, is the sum. We add them all up. Okay. Okay, and we get 32.3. So in this case, mu is equal to 32.3. That's the expected income of a super shopper, which is what they're asking for in this problem. Okay, so that's how you calculate mu in a binomial, not binomial, in probability distributions. So, okay, non-binomial probability distributions. Okay, and then she also wanted us to take a look at part D, which is to do standard deviation of the income of super shoppers. Okay, and we have a formula for that as well. So that standard deviation is equal to the square root of sigma, or the sum of the individual x values minus the mean of the x values, which we just found, all that squared, times the probability of each individual x value. So we're going to go ahead and do another chart for this. I think I'm going to do it below, well, let's see. We'll try to fit it in here. Okay, so again, we've got individual x values, so we've got same ones. So we've got 10, 20, 30, 40, 50, 60. And this is just my method of organization. You don't have to do it this way. I just think it's the most efficient way of doing it, personally. So, best way to save time. Okay, and then we're going to do x minus mu, because we're following order of operations, so we have to do what's inside the parentheses first, and that's x minus mu. Okay, so we're going to do, that'll be, excuse me, 20 minus 32.3, 20 minus 32.3, 30 minus 32.3, so just each of these x values minus the mu. 350 minus 32.3, 60 minus 32.3. So if you guys remember all the way back to like chapter 2 when we were doing this, it's kind of tedious, but once you get it down, it's a pretty easy process, thankfully. Okay, so that's going to be negative 22.3, negative 12.3, negative 2.3, and then 40 minus 32.3 is 7.7, 17.7, and 27.7. Okay, and then we got to square those values. Okay, 22.3 squared is 497.29, and try to keep as many decimal places as you can so you don't throw off your numbers. Okay, 12.3 squared, that's going to give me 151.29, 2.3 squared, 5.29. Okay, sorry about that. Okay. Okay, that's 59.29. Okay, 17. 313.29. And 27.7 squared is 767.29. Okay. Cool. Alright, so after that we're going to take each of these values that we just found, these squared values, and we're going to, I'm going to move this down here so I don't lose track. Oh, that's a terrible looking arrow. You get the idea though. Okay, so once we have these values, we're going to be multiplying by p, the probability of the original x value, and that's the original x value that you used to get this squared number. So we got 497.29, and that was when our x value was 10, so therefore we're going to be doing 497.29 here. I'll write all these down here. Okay, 497.29. Sorry if you can't see this, you'll see it in a moment. Okay, so and just as a reminder, all of these values here, this is our x minus mu squared values. Okay, and then we're going to be doing the next step, which is to do x minus mu squared times the probability of x. So for this one we've got 497.29 times the probability of 10, which originally is 0.21, all the way back from the top. So like I said, this is a very tedious process. 51.29 times 0.14, again just 0.14 is the value for 20, and 151.29 is the value that we got when we did x minus mu squared, when x is 20. Okay, 5.29 times 0.22. Almost there, guys. And unfortunately, this is about as fast as you can do this. Okay. I mean, maybe you're faster than I am, but this is about as quick as you can be. 313.29 times 0.20 and 767.29 times 0.08. Okay, so I'm going to do that really quickly. And then our last step is going to be to add them all up. So whatever these totals are. $497.29 times 0.21. Okay. Like I said, try to keep as many values as you can, but if you do a little bit of rounding, you should be okay. Okay, almost there. Sorry about that. Okay, and then we're going to be totaling these up. So we're just going to add all of these up. 62.638. Okay. Give me a sec, sorry guys. Okay, which gives us a grand total of 259.6905. And if you look back up at our original formula, we're taking the square root of the sum, so we're doing the square root of this number. So the square root of 259.6905 is equal to 16.115. So the standard deviation for this probability distribution is 16.115. And there you go. Okay, so that's 5.1. I know that was kind of long, but that's the nature of this kind of problem. So the other one shouldn't be as bad. Okay, let me flip over to 5.2 here in my book. Okay, now we're talking about binomial probabilities. And just as a refresher, a binomial probability is any kind of probability experiment where there's only two outcomes, being success or failure. So any experiment with only two outcomes, success or failure. Okay, flipping ahead. Almost there, guys. Okay, here we go. Let me see. Okay, let's do... If you guys have ever been to my review sessions, you know this is what I'm like when we actually do the review session too, so you'll be familiar with the fact that I'm like picking problems as I go here. Okay. Let's do number 19. So this is a fun mother-in-law problem that I'm sure the authors of the textbook really enjoyed. So this is section 5.2, number 19, page 225. So 5.2, number 19, page 225. Okay. So the question says, sociologists say that 90% of married women claim that their husband's mother is the biggest bone of contention in their marriage. Suppose that 6 married women are having coffee together one morning. What is the probability that all of them dislike their mother-in-law? Okay, so we know we're dealing with a binomial because they either like their mother-in-law or they dislike their mother-in-law. There's only 2 possible outcomes. At least the way we're categorizing things. Okay, so A, all of them dislike their mother-in-law. So the probability, oh, actually, we need to pull out some formulas here, so we need to talk about those before we do anything. Okay, so the formula for binomial probability distributions is one that you guys have kind of used a lot already, but I'm going to write it out here anyways. So that's the combination of n and r, parentheses, times the probability of success to the power of the number of successes desired, times the probability of failure, q, to the power of the total number of trials minus the number of successes. Okay, and just so you guys know, this C and R, C is not a variable by itself, it just means combination formula. So for those of you guys who don't remember, combination formula looks like this. It's R factorial over n minus R factorial. Okay, hopefully you guys can read that. Yeah, so just so you know, I'm doing it this way so that I can kind of save some time here and so that these problems can be a bit shorter. But it is totally possible to do, to do this using, like, by hand, and then you would just be using this formula for n and r in place of the c and r. But otherwise it's the same process, and then you would still multiply it times p and q and all that stuff. Okay, so first thing we're looking for is what's the probability of success, and in this case success is defined as not liking one's mother-in-law. So the probability of success, which is a lowercase p, is going to be 0.90 because there's a 90% chance that someone doesn't like their mother-in-law. Okay, and if there's a 90% chance that someone does not like their mother-in-law, then there's a 10% chance that they will like their mother-in-law. So that's just the complement rule. 1 minus 0.90 gives us 0.10. Okay, n, that's the number of trials. In this case, there are 6 married women who are going to have coffee, so there's 6 total people. And r is going to change depending on what they're asking of us. And in this first one, they're asking us the probability that all of them dislike their mother-in-law. So we're looking for the probability that r is equal to 6, that all 6 of them do not like their mother-in-law. Okay, so let's get to it then. So we're just going to plug everything in then. We're just going to stick everything into our binomial probability distribution formula and go from there. So we're going to do the combination of n is 6, r is also 6, times p, which is 0.90, to the power of 6, times 0.10 to the power of 6 minus 6. Okay? And then real quick, quick tutorial on how to do this on TI-83 calculator. It's totally possible to do this on other calculators, but just a quick show. Okay, so what we're going to do here, so I believe we go to, let's see, let me check really quick. I want to give you guys, okay, yeah. So on this one, you're going to click, well, first you're going to put in your first number. So our C, we've got C, 6 and 6, and essentially this is n and r. So n and r. And on your calculator, the format for this is going to look like this. So n is, sorry, that's going to be NCR, like that is how your calculator is going to show it. And so what you're going to do is you're going to type it in like this. So you're going to put in the 6 first, and then you're going to find the C and R, which I'll show you how to do in a second, and then you're going to put in your R, which is also 6 in this case. So what you do here is we're going to put in our 6 first, and then we go to the math button, which is right there, and we scroll over to the right until we get to PRB, which is probability, and you go down to NCR, which is the third one, and you hit enter. So it's going to go 6 NCR like that, and then you plug in the other 6 and you hit enter. and that happens to be 1. Okay, so that's the first part then. So now what we have, we've got, here, moving down this way, so now we have 1 times 0.90 to the power of 6 and 0.10 to the power of 6 minus 6. Okay, so really quick, 1.90 to the power of 6, and then we're going to have 10 to the power of 0 because 6 minus 6 is 0. Anything to the power of 0 equals 1. So well, we're going to have 1.90 to the power of 6, and then this 10 to the power of 0 also becomes a 1. So all we have to do is 0.90 to the power 0.90 to the power of 6, which is 0.531. So there you go. So the probability of R being equal to 6, the probability that all 6 of them don't like their mother-in-laws, is 53%, or 53.1%. Okay, so that's A. So let's look at B. Okay, the probability that none of them dislike their mother-in-law. So the probability that R is equal to 0. Okay, same process. So we're going to go... so we go C, 6 because our n has not changed, but now our R is 0. So that's important to note. R is now 0. And then we have 0.90 to the power of 0, right? Wait, did I write that down correctly? Yeah, I did. Okay. And then, here we go, 0.10 to the power of 6 minus 0. Okay, so again, I'm just going to do combination formula, and just as a quick review. So we're doing C, combination of 6 and 0, so we plug in 6 first, math, scroll over to probability, down to NCR, which stands for combination, and then 0, our R is 0. And we hit enter, and that is also 1. Okay, so that's 1. 0.90 to the power of 0 is 1. And then, oh, sorry about that. Jamie, can you grab him, please? Thank you. Oh my lord, my apologies.
Shadow!
It's good to be home. Okay. Okay, so all we're going to do is 0.10 to the power of 6, because that's the only one we have to actually calculate. Everything else is already done for us. Okay. So 0.10, nope, shh. Okay. That gives us 0.00006. No, sorry, 0.0001. Okay, which is basically 0. So just so that you know, that's essentially 0. So the probability of R is equal to 0 is, so the probability that out of 6 women having coffee, all 6 of them don't like their mother-in-laws is essentially 0. So there you go. Okay, cool. Okay. And then I'm just going to show you how to set up the rest of the problem, because I don't really have time to do the whole bit, but okay. So part C says, what's the probability that at least 4 of them dislike their mother-in-law? So how would we write this? So at least 4. So that means it has to be 4 or more. So the probability that R is going to be greater than or equal to 4. So that's what we're looking at here. Okay, R greater than or equal to 4. Yes. So what you would do is you would essentially be doing, let's see, this could be the probability that R is equal to 4, and the probability that R is equal to 5, and the probability that R is equal to 6. That's everything that's 4 or greater. And you're going to find, they're asking us for the probability of everything that's 4 or greater. So we have to find 4, 5, and 6. So you would just plug 4 into the into this binomial probability formula that we've been working with. You'd plug 4 in and get the answer there and then write that down. And then you would plug 5 in and get the answer and write that down. And then you would plug 6 in and get the answer and write that down. And then you would add all those together. Now, there is a shortcut to doing this that I'm going to use, just for the sake of time. I don't, basically it's going to depend on whether or not Ms. G gives you guys a binomial distribution table